Here in this video, we're going to try and develop the tools we have for coding and introduce a very powerful coding tool, or ultimately coding practice called functions. Okay, now functions are a great way for if we're repeatedly maybe doing a particular sequence or action within our code, that we can create a function that will continue to repeat that at different stages, and maybe even with different parameters throughout the code. And also, functions give us a great way of organizing our code. It allows us to see maybe where issues are occurring, and we can pinpoint our code a bit quicker and help fault find it. So let's take a scenario here. All I've done is I've just set up a project, right? And ultimately what I want to do is, in my main block, I'm going to, let's say we're going to start a conveyor, okay? And what's going to happen is, as say a package enters a conveyor, okay, what's going to happen is there's going to be a particular sequence that happens with some actuators. It's going to run along the conveyor, and then at the end the same sequence is going to happen, okay, but just with different inputs and outputs. Okay, so we're going to have a look at how we can do that. So really, we do need to start setting up our tags here at the start. So we're going to add in an input table and an output table. Okay, so standard good practice, just to get in our inputs and to get in our outputs to see what we're dealing with in this task. Okay, so let's go into our input table. I'm going to have a start. Okay, I'm going to have a stop. I'm going to put one of them in. I'm going to have a toggle in, toggle switch. It's like an on-off switch or key switch, just to show something as well. Then what I'm going to do is I'm going to put in the inputs, the kind of sensor positions of my actuators, my RAMs. Okay, so I'm going to say I'm going to have two cylinders that are going to do a sequence of cylinder A and B. Okay, so what I'm going to have is I'm going to have A min, so the minimum position of A, and the max position of cylinder A, and then ultimately I'm going to have B min and B max. Okay, so that's at one end of the conveyor. I have two cylinders there that are going to do a particular sequence. At the other end, I'm going to have two cylinders again, two different cylinders. They're going to do the same sequence, okay, but this time it's going to be, I'm going to have my C cylinder, so the max and min positions for that, and then my D min and D max. Okay, so plenty of inputs there, 11, and all set up correctly. So on my outputs, well, what's going to happen? Well, I want the motor to turn on, okay, just conveyor to kind of turn on at the start, and then what I'm going to have is we're going to have cylinder A, okay, and the extension, okay, the solenoid to extend it. This didn't really spell that. EXT. The retraction of A. Same for B. Extension and B retraction, and then the same for our cylinders at the other end. We're going to have extension and retraction, and then the extension and the retraction. Okay, so we've set up our outputs and our inputs, and hopefully you get the idea that we have a conveyor that's running along. At the start, we're going to do a particular sequence with our actuators, and then what I'm going to do is I'm going to do the exact same sequence, but I'm going to use different inputs and outputs. I'm going to see how we go and code that. So in under my main block, when I start coding, okay, what I'm going to do is I'm just going to set up a basic kind of start condition for my conveyor to start, let's say, okay. And what I'm going to do is I'm going to introduce this idea of, we looked at the idea of memory, okay. Let's just say we have a particular sequence. I'm going to turn on a memory bit here in a minute. So let's say our start button needs to be actuated. I also want my toggle to be on, okay? And what that's going to do is we're going to latch it on, provided our stop button's not hit, and it's going to turn on a piece of memory, okay? So I'll need to introduce a new table. So we've seen, how to add in a new table, and we'll call that memory. And rename, so my memory table. And just in here, what I'm going to do is we're going to have a start condition, and then what I may use as well is let's just go end condition, okay? Just check in on our addresses. We want them to be memories, okay? So you see the drop down there for inputs, outputs, and memories, and we're going to start that back at the start, okay? And we can pull that down and overwrite that tag. Okay, so we some memory, and actually I probably, you know what I haven't done, when I set up my outputs, they were not set as queues. Okay, so good spot to tidy that up. 0 from 0, and then we can just pull them down and overwrite the tags. And I actually introduced a new tag there, so I can just delete that. Okay, so this is a setup, right? So let's go back into our main program, see what we're doing here. So what I'm doing is I'm setting up a start condition to trigger ultimately this memory bit that's going to say we're ready to have this start condition happening. And I'm going to latch that condition on. So start condition, and we're happy to latch that in here. Okay. So what's going to happen is I have a particular, so I have two inputs that need to be ANDed together to latch on the start condition to say we're ready to go, ready to start, and it can only be broken with a stop button. Now what that is done by setting up that as a memory input, I can use that memory input then just to trigger to say yes, we've reached our start point, we're ready to rock, and we can trigger other statements further down. What this piece of control does give us is, if we needed to change the start condition, say we need to add in more inputs or add in different scenarios to get that to turn on, the fact that we just have this start condition, if we needed to change it, we only need to change it in one place, and then everywhere else I've referred to a start condition as an input to trigger it will automatically update. Whereas if I didn't have this, if I just use this as my start condition, these two sequences, then every line that I needed to put in a start condition, it would ultimately need to be edited. So maybe you've picked up on that, and we'll see it in action here as we go. Alright, but that's just a start condition. I just want to kind of trigger them to inputs and latch on that memory bit. Now if we go into our program blocks, this gets into the part where we want to look at the function. Okay, you'll see we can add in a new block. So we've organizational blocks, we've function blocks, we've functions, and then we've a data block. Now we will eventually kind of talk through all these in good turn, but if we look just at a function block, you'll read the description of a function block and you'll see that ultimately we get their values remain available after the block's been executed. So ultimately we have some memory being associated with that. Now all we're doing is just sequencing. We don't need to retain any memory or give out any kind of data, so we're just going to do a function, so just kind of a code block or subroutine without dedicated memory. I'm going to code it in ladder logic, and we're going to give it a name, okay, and I'm going to call this a sequence, and I'm going to call it A plus B plus A minus and B minus, because that is the sequence I want the cylinders to work in. That my first cylinder is going to extend, my second cylinder is then going to extend, then my first cylinder is going to retract, and my second cylinder is going to retract. Okay. So that's going to create a new function in here for us, a function block. So it's organized in here. So I can go in, and now when I double click on this, okay, we have it open here. This is just the code for this function. Okay, so what do I want the function to do? Well, I need to give it inputs and outputs as well. Okay, it's going to have a certain amount of inputs and a certain amount of outputs. So you're going to have your sensor positions again. You're going to have A in, A extended. You're going to have B retracted and B extended. Okay, they're going to be, and then in your outputs, ultimately you're going to have the output to send A plus. You're going to have the output to send A retracted. You're going to have again the output to send B plus and B retracted. Okay. Now what these are is these are ultimately the inputs that need to be used for your function to occur, and then what outputs is going to happen. So what might be best to see is, let's say if I go back into my main program, okay, and I'll drop in my function block. Okay, what you can do is you can drag and drop that into the center. You'll see it now asks for certain inputs, and then what it'll do, it'll run a function, and depending on the outputs, it will trigger them in whatever way this function states. Okay, so you see I can start linking in here to different calls. So let's just go back into the function and kind of start explaining what we want it to do. So ultimately, I want A to extend out first, and A is going to extend out ultimately when everything is retracted. So when A is fully returned and B is in a fully returned position, we're going to go ahead and turn on an actuator to send A positive. Okay, and you'll see you'll see the hash keys. That basically means it's internal into this function. It's localized. We call this local memory, localized into this function. It's not global. So if I was in my main data block and I wanted to reference something in here, you know, we wouldn't necessarily have access to it. Everything in here is local memory, and we're keeping it localized in here, which means it's more modular. It means it's more ultimately flexible. What I want to do is I want to copy a lot of these lines down. Actually, that's the wrong symbol, so you can quite easily double click it and just change it back to normally opened. Okay, I'm gonna, until I copied that line, copy. Okay, not let me do that, never mind. Again, we're just going to have two inputs, going to trigger an output. So the first thing sent A out. So when A goes out, we're going to have A1 is going to be triggered, and ultimately B0, and that's going to send B into the extension. I'm going to have similar setup again down here. Again, two inputs. Going to trigger an output. So when we get, so B has gone out, A is extended, and B is now extended. So we want A to go back in. There. And then finally, oops, one too many, no. A has now returned home, and B is still extended, so we want B to come on home now. So that's just me setting up my sequence, okay? A goes plus, then B goes positive, then A goes minus, and B goes minus. So that's my function, okay? So I've coded that in there. That's the sequence I want to happen. So if I go back into my main, I can start kind of hooking up to this function. So this function will take any two cylinders and operate it in that sequence. So seeing that we're doing this at the start first, what I'm going to have is I'm going to put in our A min input is going to match up to minimize. Then you're going to have an A. Hang on, that's the one. The first one is it? A min, you're going to have A max, and then B min, and B, oops, B max. So what you're doing is you're taking them limit switch and you're kind of matching them to the first cylinder and then to the second cylinder. Okay, and then again we're going to have a extension, you're going to have a retraction, B extension, and then B retraction. Again, matching up what outputs you want to control, because we want to put them in this order. So you see you've got that function block in, we've matched up our IO. Now we can also do is we can put in a star condition for this. So we want this to ultimately only come on when the star condition is ready. Okay, so when the star condition is fulfilled, it's going to trigger the sequence to start it. So you see that flexibility. We could have just put, we could have put them two lines, or this whole line ultimately, in up here. But if I needed to change it, and if I had multiple kind of scenarios where I was using that, I would have to change it every time. But now that I've just put that one marker in there, if I ever need to change the start condition, I can change it here, and then anywhere else, the start condition will automatically update. Okay, so ultimately what that's going to happen is when the first sequence is done, what it's going to do is we're going to trigger another piece of memory. Okay, so let's see, ultimately when that all runs through, it's going to come out, trigger an operator. Let's give it, well, not so much the end condition, I might need an extra piece of memory here. I want to call one the time interval. Okay, because what I'm going to do is, if we go into our main, we can trigger that time interval memory. Now I'll tell you what we'll do is we'll just run that sequence, and then what we'll have is we'll set up another end condition. Okay, so what I will need to do, instead of adding in that extra bit of memory that I needed, okay, get rid of that and delete, take another input in, and we'll just say down as it's passing down the conveyor, it's going to go past some sort of optical sensor. Okay, so when it triggers that optical sensor, then it's at the end of the conveyor, and we're ready to run the next sequence. Okay, so we'll go back in here, and we'll come down here, and we'll just feed in again our optical. So when that's triggered, what we want to do is we want to latch on our end condition. Again, I'm going to make sure my stop button can kind of override it at some stage, and we are going to just latch that end condition on. And you see this does leave us flexible as well. If we need to change the end condition, we need to add in more kind of statements in here, we could do that, which would change our end condition first. And then here's where we really eventually kind of get to the usefulness of the function. So it's going to happen at the end of our conveyor, but it's going to be the exact same sequence first. So I'm taking in the same sequence, so I don't need to recode it again. I'm going to give it the end condition. Okay, so when the end condition is satisfied, it's going to trigger that sequence again. Just dropped in the wrong symbol there. Okay, and then what we're going to do is we're going to run a sequence again. First cylinder, don't get confused I suppose with the A and B's here. This just means the first cylinder is going to extend, second cylinder is going to extend, first cylinder is going to retract, and then the second cylinder is going to retract. So that's going to do that sequence now, but it's going to happen at the end of our conveyor, which means we're using different inputs and different outputs. So I can now use the C and D, So during my new inputs, and then the new actuators for that is going to be my C extension, my C traction, my D extend, my D retraction. And that will run that same sequence but just in a different place, and I don't need to recode all that again. I can reuse that information because it's the same sequence. So that in essence is how we put in function blocks and how we use them. And you'll see if we just look at this layer of code, if we didn't have these in, there'd be a lot of lines of code, you know, and they'd be interlinked in whatever way is necessary. But here we have a beautiful structure now, is that we know how to start off our conveyor. I actually never even turned on my conveyor yet. We could put in another network there just to start our conveyor. I suppose we best just do that. Insert network. Just put it in here, just to kind of keep it nice. Again, we'll do something similar. We'll take a start condition. The start condition satisfied. We'll turn on our motor. Kind of forgot about it. And we'll allow our stop button to override it. And then we will latch that on. So we'll come down here, bring in our latch, linking that back round, and then join that up. Okay, so ultimately, again, we start our motor, we have a start condition there, and we see how our motor's turning on. Then we ultimately see how the first sequence is triggered, and then how the end condition and our end sequence is triggered. So it's nice and segregated there. And then ultimately, so if that's running okay, maybe there's a problem then with the sequence, and if the sequence is not working, then we can go into actual code of the function and see, right, maybe there's an issue here with how I've coded the sequence, or maybe there's just an issue of how I've linked in the inputs and the outputs. Have I linked them in to the correct mean? And so is a min referencing the initial position of the first limit switch? Yes, it is, but maybe there was a mistake there. So hopefully you kind of get the idea of a function block, how we can bring it in and utilize it, especially if something's going to be utilized a number of times. We want to keep that in. But even if it's not going to be used a number of times throughout it, it gives us organization and it keeps code modular, so we can pick it in and out. You can ultimately save these functions into the library, and you can use them across multiple projects to save you having to build them up again. So a lot of capabilities there. Hopefully it makes a bit of sense. I know it's a bit of a long video, but yeah, hopefully you get the idea of using that just for an example with a conveyor. It's not perfect, but you know, hopefully you get the idea of the function blocks mainly.